Hi Geometry, welcome to 6.5. It's really rainy and nasty outside. Hopefully you're staying inside or keeping busy doing something. Here is use proportionality theorem. Okay, so this is going to look pretty different from your notes, but the content's the same. Like I got rid of this black stripe. I reprinted it for sizing, so since I need that space. I didn't want to reprint another more sheets because I'm trying to keep down my copies. It was actually a goal for this year because I usually go crazy with copies. Hope you understand. All right, so here we go. Proportions. That's exactly what this whole thing is about. So I can use proportions with triangles or parallel lines, and I can use perspective drawings. So that's pretty much the whole theme of this chapter, basically. So give the postulate or theorem that says why these triangles are similar. This is supposed to have an 80 and that's supposed to have an 80. Okay, so I have this angle is congruent to this one, and they both have this top angle, so it'll be angle, angle, similarity. All right? So, next one. Solve. Let's cross multiply and solve. So I have 16x is equal to 32 times that quantity, 12 minus x, and I'm going to go ahead and distribute. Could divide both sides by 32 and I'll get a half, but that freaks people out. So 16x is equal to 32 times 12 is 384. And then minus 32x. I'm going to add 32x to both sides. And then divide both sides by 48. Please double check my work. All right, here we go. Theorems. There's some good stuff here, and a lot of students, they forget these theorems specifically, but they know that there's proportions involved. So here we go. Triangle proportionality. If a line is parallel to one side of a triangle, for instance these two, and intersects other sides and divides the two sides proportionally. Okay, so if TU is parallel to QS. So here we go. We have the parallel lines. This is what you start with. Then RT, I'm going to call that 1, over TQ, we'll call that 2, is equal to, I don't want to use that. I don't want you to look at it as a number. RU, which is 3, US, which is 4. Okay, so these are not numbers, but we'll just say side 1, side 2, etc. So just this one over this equals that one over that. There you go. Okay, now the converse of the triangle proportionality theorem. So here's your converse right there. If the lines divide them into proportions, then the lines are parallel. So remember, converse switches them around. PQ, now QP. All right, so far so good. And I look, it's still recording. Yay. Here we go. You ready for this? Contrapositive. Uh-oh, something happened. I'm missing example 1. Oh, let's do example 1 first. Okay, they're parallel. QS is 2, SP is 6, PT is 9. Find the length of RT. So 6 over 2 is equal to 9 over x. Cross multiply and solve. X equals 3. Sorry about that. Now we're on the contrapositive. How did my pages get really messed up? Okay. Trying to figure it out here. So, remember what a contrapositive is. They switch them around and then they negate them. Okay, so let's say they're not proportional. That means they are not parallel. So, when an if-then statement is true, its contrapositive is also true. So the theorem for the contrapositive for 6.5, if they are not parallel, then they are not proportional. I think they have those two switched around, don't they? Okay, doesn't matter. Just know the contrapositives are not. Okay, number 2. The picture's not here. So we have a treehouse. You like that? Okay, and there's a brace. Looks pretty jacked up. This length is 20. This length is 20, 16, and 24. So a brace is added to a treehouse as shown. Okay, so S to T. Explain why the brace is not parallel to the floor. So how come ST is not parallel to UV? Well, let's look at it. If they were parallel, these sides are proportional. So 16 over 24, does that equal to 20 over 20? Nope, not parallel. Okay, here we go. Theorem 6.6. If three lines, this is line, looks like V, T, and X, intersect transversals. Okay, these lines are parallel. Notice the little angles here. We have two transversals. Then they divide the transversals proportionally. So this part over the top over the bottom equals the top over the bottom, or the top over the whole thing equals the top over the whole thing, or the bottom over the whole thing equals the bottom over the whole thing. So all of these hold true. I kind of like that. Okay, so this is actually important. Theorem 6.7 is another good one. Now you're probably understanding why students kind of forget these, but just remember, everything's proportional. So if a ray bisects the angle, that means we know that's going to equal that. Then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So what does that mean? Okay, so AC bisects, that means BC, this length over this length equals this length over that length. Okay, so you do these two, then these two. Try to do your best. Try to remember those. I'll probably have this posted on the wall, at least these two. Okay. What's next? Example 3. Of course, there's a crazy diagram here. So I have 3 streets. And 2 cross streets. Q, R, S, T, U, V. This is 160 meters, 320 meters. This is 340. And we don't know this. This is First Street. This is Second. This is Main. Ugh, the ink is leaking on my hand. Okay, so these angles right here are all congruent. When those angles are congruent, they're telling me that these lines are parallel. Okay, so that means obviously these angles will also be congruent because these are corresponding angles. So all those lines are parallel. That means the side lengths have to be proportional. So 160 goes over 320, x over 340. Cross multiply. Please double check this math. X is equal to 170 meters. Now you got to be really careful because is that what the question asks? It says find the distance between First and Main. Okay, I found out what X was, but I didn't find that whole length. So between First and Main, just take 170 plus the 340. That's equal to 510 meters. All right, last one. Wonder why I didn't have any of these diagrams marked. Okay, so in a diagram, triangle BAC is congruent, angle BAC, this one right here, is congruent to DAC. So that means this bisects. So we're using that last theorem. Use the given side lengths to find the length of DC. Okay, well this whole length is 40, and this part's X. So that means this is going to be 40 minus X. So to set that up, I have to take this over this. 40 minus X over X is equal to 32 over 24. So you definitely want to remember this formula. Okay, so this section has quite a few of these. Cross multiply. 24 times that quantity, 40 minus X. I'm going to distribute 960 minus 24x. I'm going to add 24x to both sides. And then divide by 56. So again, double check, make sure I didn't make a mistake, and don't be afraid of having numbers that aren't really nice and perfect, okay? So here's our homework assignment, and here's our Common Core Standard. I am off to go see Blaze's soccer game at the Boys and Girls Club. Have a nice evening.